Hello, everyone. Today is going to be a little bit weird. I usually script things out, get ChatGPT to help me, but today I'm just going to shoot things off the top of my head and see what happens. I'm going to be talking about shifting left and the challenges that I have personally faced trying to get people to shift left. So let's jump into it. Part of my shift left strategy is in my free guide. It's the top 5 test automation best practices. It's down in the description. There's a little link there. Grab it. It's free. But yeah, shifting left. So if you're not familiar with what shifting left is, so let me start with what shift left. Let me start with what shift left is. Back in the olden times, where software was pretty much owned by Microsoft, there was this thing called waterfall development, which means the developers, actually project managers, whatever, they wrote all these specifications. Then the developers went and developed and developed and developed and developed. And at the very end of the project, testing happened right before it was released. There was a lot of problems with this, and one, as the developers were developing, they strayed from the actual project requirements, and also there was no unit testing. There was no checking a bug, so they would get something working, then it would break again, but no one knew if it would break. So by the end of it all, the testers would have to go to these docs and say, well, none of this applies anymore. None of this software it's too late now to change anything. So you have to test what is there, and then you have to decide what's a bug, what's not a bug. You have no docs to really refer to, so almost everything is a bug, but it's just too late to change at that point. And it's also probably too late to test. There's only when you're at the very end of this project, you can only, most likely you're going to let a lot of stuff slip by because you can't test everything at the very end. It's just too much stuff. And there's probably way too many bugs to even sort through. So you're not going to get finished. You're just going to keep finding bugs, opening a bug report, finding a bug, opening a bug report. And then, they have to ship. And a lot of companies just popped out all this really horrible code. Companies went out of business because their releases were so bad because of this. So that was the whole thing where agile testing came in. Let's do things in shorter sprints, like little 2-week sprints, ship something out, a very bare minimum workable thing, and get feedback and then loop back. And that's kind of the paradigm that we're in now. Testing, though, is always talked about but rarely done in these cycles. But shifting left is the idea of, instead of waiting to the end of everything, like the waterfall, you don't want to wait for all these sprints to go by and then test right when it's about time to go out, because you're basically still in waterfall mode, even though your team is practicing agile. You just basically have 2-week sprints and it's in a waterfall model. So the idea of shifting left is let's test this stuff and get it working and get it stable and have tests running. So that way, when we do have something that's working at the end of this 2-week sprint, there are tests there. We know it works. And then when we go to the next sprint, the tests are there, they're working, they're preventing things from getting shipped out to the customer. And also when we start working on new code, the old test prevents us from breaking working features that we're shipping to the customers. That's the basis of shifting left. The further left in the SDLC, software development lifecycle, the further left that all the testing can come, the cheaper the cost. So imagine the waterfall model I was talking about before. It could bring companies down. It could actually cause companies to go out of business if they release really horrible software. That's the extreme right there. That's the extreme. But the thing is, the cost is astronomical at that point to test at the end. Move it over a bit, you can catch things earlier, and that cost goes down. Okay, now you're testing in the middle. Okay, cool. We found a whole bunch of problems, and then the cost goes. So if you take that model, keep shifting it over earlier in the process, the less cost it is to the company overall. Less cost of wasted time and breaking features that were working, less cost in angry customers, less cost in like customer support, because you have tests that are testing everything, you're catching those bugs before they're shipped out. Even though you're writing more tests up front, it actually makes things go faster. I'm probably getting ahead of myself on that one, because there's some, even though this sounds like a wonderful, beautiful thing, there's a lot of resistance to actually implementing it, because doing it is hard. It's a discipline, and it takes skill, and it takes a lot of failure before you get it right. So I want to dive into that a little bit more. Again, I've got a few of these principles of mine, like how I've approached testing, in the free guide below. It's the top 5 test automation best practices. The link is down there. Yeah, I share like 5 like basic principles, easy for you to read, and some of those things I've used to help me shift left in whatever company I'm working for. But let's transition to what my ideal vision of shifting left would be. So that's this next section. So my ideal vision of shifting left, and I think a lot of the developer community would agree with me in principle. In practice, not so much, but in principle. The tests should happen immediately. Some should even say that you write the tests first and do a test-driven type thing, but not even going to go there. Test-driven development is a personal preference for developers when they're writing their unit tests. But that's the thing, unit tests. That's the very first part. So you write your unit test with your code as you're writing it. So when you check in, you have a set of unit tests for the code you have developed. The unit tests are that first the first part of the gauntlet to prevent bad code from going out there. So developer writes the unit tests. In a shift left paradigm, those unit tests run before they can even merge in. And there's a couple ways of doing that. First, you can have hooks in Git hooks. Developer can do them themselves. I think that's how Git was designed. Each developer can do their own Git hook. And there's a .git/hook or hooks directory in your project. That's where these commits go. These are usually controlled on the developer's machine. However, there's been a lot of tools put out there like Husky and whatnot to have it implemented for everyone. So everyone's using these same hooks that will run those tests ahead of time right when you merge in. So you have your test merged in. I would say that you also don't trust the developer. So once they have merged in, there's the CI/CD pipeline, which will then, before the code merges into main, and I guess I should say when they're originally merging, you merge into your branch. So all this is happening on your branch. Before you can get from your machine into the branch in the repository, your test should run. You should have some formatters. All that stuff should be taken care of before it even gets up there. But just to be sure, once your code is in your branch, that stuff, the CI/CD pipeline should run it all again. It should run those tests, because never trust that the developer has run the unit tests. Never. Because I got yelled at once in my career. I was working at Microsoft. The developers weren't running unit tests, and they yelled at me for it. That the code was all buggy because I wasn't running their unit tests that they were responsible for. Some shit, right? Anyway, so you should have the CI/CD pipeline run those, because developers can bypass that stuff and put -- no verify and skip them. You don't want that. But anyway, yeah, so the unit test run gets up there, and then once it actually hits that CI/CD pipeline. In an ideal world, the end-to-end tests would also run against that branch, targeting the specific features that the developer is working on. So if the developer touches files X, Y, and Z in a project, then there should be a corresponding thing that triggers tests that are related to those. There should be like a smoke test that tests everything, the basics of everything. And then there should be more targeted tests towards that. And that just makes sure that as unit tests, as great as they are, you can have 100% code coverage in unit tests. They could all be passing perfectly, and your code can still be buggy and as hell and completely incorrect and broken. Unit tests are good, but they're only as good as the developer writing them, and it's only good as the code being implemented. End-to-end tests, on the other hand, and you have nowhere to hide. Unit tests, you can mock things out and change things so you can get whatever values back from whatever, but in end-to-end test, you're dealing with a production-like system. You're actually running things as the user would, and that's the important part, as the user would run things. So you have your end-to-end tests kind of run against that, and if those break, no, you do not pass go, you cannot go forward. Those should be preventing, you should have these like small minimal set of tests preventing you from merging into the main branch. So let's say you got those end-to-end tests, you got your unit test, and then you make it into the main branch. That's when you should have a more comprehensive set of tests that go out that prevents things from going out to production. So production is, of course, where the customers are getting the code. So you want to make sure that code does not go any further if it's failing any of the tests, because a developer working on feature X, thinking they have nothing to do with feature Z over here, magically, that one little thing, there's some interdependency no one knew about that will cause this feature to crash the other feature. It happens. So you want to make sure that nothing anyone has broken anything, unexpectedly. So those run, you got a nice gambit of tests, then it's released out to the customer. And then I would say at that point, you also have tests running against production. Maybe not as intensive, but you want some assurance that the production environment is working, because where you run those other tests are not the same as that production environment. So there could be differences. Then you run those there as well to make sure things are working for your customers. And also you have monitoring systems. Like there's a company called Datadog, and there's a whole bunch of cool little services or whatnot that can monitor to make sure nothing's happening. Like seeing if there's any of your APIs are suddenly returning a whole bunch of, the customers are hitting a whole bunch of like 404s or 500s or something like that. Then, or if databases are going down or something wonky is happening, there are some monitoring services. And so when you get to that point where you're running things in production, that is shifting right. And that's good. You should have tests that both shift left and right. So that's not an incorrect thing to do. So that's a very simplified view of basically a set of gambits. Like your code has to run go through a little simple thing just to get merged in, then it has to go through a few more complex stuff, and then finally it wants to go to production. It needs to have a rock solid, stable, full pass release, then it goes out. That would be my ideal view of things. But there's a lot of problems with this. And in the next section, I will delve into some of the problems with shifting left. Okay, so here are some of the problems with shifting left. I've been in a company, a smaller startup, where I was able to get people to start testing early and getting their unit test. We had integration tests, we had E2E tests, we had all these things going, and it was beautiful, it was wonderful. A lot of testing, but man, rock solid. Then the company didn't have a good business model, and they went out of business, unfortunately. But man, I was so happy to be able to get that shift left process going. And then I went to a big giant company, and shifting left is very problematic. It's very difficult. So here are some of the issues against shifting left. And I'm saying don't shift left. You should always be trying to shift left, because that will save your company a shit ton of money. But shifting left can cause a lot of problems. First of all, you need developer buy-in, because developers are overworked. They have a lot of shit they do. They have a lot of responsibility for the code that they're writing to actually get out there. It's also a business push that they need to get that code out there in a certain amount of time. And it's usually not enough time ever. The deadlines are never long enough. But it's a real thing. You need to get the code out there. You need to hit your business deadlines. I mean, I was talking before about code going out so buggy that the company went out of business. But if you don't ship code at all, or you're extremely late, that's another way to go out of business or start losing money or get behind your competitors. So there's that balance there between, extreme amount of testing and being able to actually ship something, even if it is buggy. So part of your job is to kind of negotiate that. But yeah, you have to kind of win over the developers to get the shift left stuff happening. It takes education. It takes monitoring. It takes winning some hearts and minds, and that is showing that tests, proving that your tests are rock solid. You have stable tests, and that these tests can catch things before things get shipped out. Every tester, every manager, every project person, everyone will say, yes, we want to shift left. But as soon as you describe the work involved in shifting left, I've had managers say this to me. They'll be like, yes, we want to shift left. I'm like, cool, this is how we do it. And they're like, no, we're not doing that. I'm like, then how are you going to shift left? But yeah, it requires, you can't have one tester on a team of like 6 to 10 developers and expect to shift left. It's not going to happen. You can't have one tester on the team writing all the tests. It's not going to happen. You're never going to get the test coverage you need, and you're never going to get it done in the time that you need. And many companies still operate on this principle. Oh, you got the one tester, they're going to write all the tests. The developers aren't going to write anything except their unit tests, whatever. This is a very flawed way of doing things, but many companies do it this way. And the reason it is so flawed is the tester can't do all that work. And the test engineer often doesn't have all the information that the developers do about what's being developed. The tester has to go and learn everything that the developer did, and sometimes those docs, the specs and the requirement docs, are not as good as you would like them to be. Often they are not as good as you would like them to be, because that you don't know, the person writing all that stuff, they have an idea of where they want to go with this stuff, but I mean, when the real code and the real world mix together, those things might have to go out the window. I mean, and also, again, there's that balance of you need to ship something. So sometimes they have to simplify or cut, or whatever the developer has might not exactly be following those docs. So there's a learning that you have to do to see where the developer is, where those docs are, and you got to, as a tester, you say, is this a bug? Just because the developer says that's the way it's working? Is it? Part of being a tester is being the customer advocate. You have to ask yourself, what would a customer think in the same situation? Is this what they would want? Then you got to look at the business part of it, and I'm like, is this, I think I'm getting off the rails here, but convincing the developers to actually participate in that coding is essential. There's no way that one tester is going to write all the tests needed for a team full of developers. Not going to happen. Even with AI, not going to happen. At least the AI as it exists today, not going to happen. So you have to, one, float the idea, and then you have to win people over to doing it. Usually I found that you get one developer who wants to partner up and starts doing it. And honestly, it's just moving things a little bit at a time. But I'm getting into the solutions here. Maybe the solutions might be the next section or another video, but you get a lot of resistance from developers and even managers because they're under a lot of pressure to deliver code. And I didn't even mention that some of these developers are sometimes on call. They're responders, and they have to like be on call to like do support if something goes bad with their code in the wild. So developers are overloaded. So when you ask them to write tests, you're gonna hear a lot of them go, just no, not gonna do it. And how do you shift left when they don't want to write tests? That's a challenge. You have to figure it out. You have to figure out alternative solutions to having everyone writing those tests. Sometimes you just do the best with what you got. Usually what changes people's hearts and minds, other than having people seeing the results of the code, usually seeing bugs go away, or seeing that you get customer support issues start going down, seeing time to development increase, or time to actually getting your project finished increasing. Sorry, I didn't say that correctly. The ability to write code faster and get your product out there more quickly is a result of good testing as well. And that's a hard thing to convince because it's not something you see immediately. There's no, you write the test and know like, oh, cool, I now have better quality shipping and faster. Usually a tester is going to say, I have to write the test too. That's slowing me down. And that's another big hurdle, is because developers think they're going to be slowed down. Though the truth is, if you have a good set of tests and you're writing tests as you go with each feature, you can write tests faster. And it's like what I mentioned earlier, is that if you have all these tests in place, then you can be very confident that anything you do, there's going to be a test that captures it if you break something else. And if you know ahead of time and really quick, and you get that quick feedback that you've broken something else, you can fix it right there and then. Versus you don't have those tests in place, you won't know until it goes out to the customer and you get a whole bunch of customers really upset. And then you're working late nights and weekends trying to fix that. As I spit everywhere, sorry about that. But yeah, that's how it works faster, but it's one of those faster things that you don't realize when you're doing it. When you're doing it, it feels slower. And that perception of slowness, a lot of developers will say no. And project managers and everyone will be like, no, it takes too long and we need to get this out. Another giant obstacle, and I think I'll end on this one with all the obstacles. Another giant obstacle is that the system that you've developed is not testable, or extremely difficult to test. And yeah, the bigger the company, the more true this is. So if you've developed this, a good way to tell if you don't have something that's easy to test, you can't run your product on your laptop, you're going to have problems. If you can't fire up a few Docker things, get a Docker Compose thing going and get it all going on your desktop and like have a minimal working product that represents everything, and you can run those end-to-end tests on your laptop, you can't do that. That's a smell, a code smell, that you don't have a testable system. But let's say, all right, you have other workarounds. If you can't do it on your machine, you have to be able to fire up independent environments that you can test against before it ever reaches the main branch or the production stuff. And it can't be one environment that everybody's sharing and messing around with, and it has to be something you can fire up for yourself, and you have your own developer or tester instance of it, or you can fire it up and have a CI/CD, put it on a few virtual machines, or fire it up and have a little environment going virtually that is independent of all the other environments going on. So you have a stable test environment. Stable being a very key word, because if you have any instability when you're trying to get these tests going to ship left, it'll come crashing down really quickly. And that's what I mean, you need a testable system. Another part of the testability of a system is developers having the foresight and including test early in the process in order to provide testing endpoints, ways of getting apps into a state to be tested. You don't want to control everything through a UI to get to a point where you test something, because that's just so, one, it's and what I'm saying is, like, hey, you want to set up like the database to have, like, say you're testing a shopping cart. You don't necessarily want to go through the store and add all the things into a shopping cart, versus you just fill up a database really quick and just have an API you call, like, hey, fill database, cool. And then you go to and then you can test the shopping cart with data in it. If those APIs aren't in place for you to do that, then it's really difficult to test. And the thing is, when developers implement those types of APIs, the system becomes more robust. You're following the CRUD principles. Be able to create a resource, read a resource, update a resource, and delete a resource. And that comes into play especially with like test user accounts. I love it when I can just fire up a test user and then delete the test user, because then I know each test I write isn't being messed with by someone else using that same test user somewhere else in the organization. Yeah, so that's some of the key points there, is that you need to have a testable system. If you don't have a testable system, you're going to be dealing with flakiness, instability. Developers are never going to use your test framework. They're never going to pitch in. If there's any flakiness, instability, anything at all, they're never going to use your system. So if you have end-to-end tests that are always failing, not going to happen. You need to find a way to make your test rock solid. And I think I do mention this flaky thing in my test automation guide for free in the description. Sorry, I'm thinking, did I actually pop that in there? But yeah, handling flaky tests is one of your top priorities. And one of the things I'm really excited about with AI now is that there can be some self-healing tests, but I haven't worked in a company that has self-healing tests yet. So I'm looking forward to seeing that day. Hopefully Cypress, my company is using Cypress. I have not seen any self-healing capabilities come out of Cypress yet, so we'll see. But those are your big obstacles. In the next section, I'm just going to go quickly, just like some ways you can kind of overcome some of these obstacles. Okay, so overcoming the obstacles of shifting left, it's really time and patience. You have to be trusted by your team. You have to show that your tests catch issues. You have to show that it's easy to run your tests. Show that your tests can run quickly. You have to know how to make your tests run in parallel. That way you're not waiting a couple hours for all your tests to run. You want your tests to run like 5 to 10 minutes. And that can be difficult to do depending on the system that you're testing. Again, that comes back to testable systems. But yeah, so designing things to run quickly and to run stably. Have a way of dealing with flaky tests. Like move them out as quickly as possible. You don't want the same flaky stuff happening every day. You want rock solid tests. So focus on keeping your rock solid tests rock solid. Have your flaky tests run somewhere else. They're still important to run these tests and figure out why they're being flaky. The flakiness could actually be a real bug in the system that's just hard to find. It could also be that what you're testing against isn't stable. So that could be like if you have like a sandbox or staging or dev environment, it might not be the right environment for your test. So that brings up the next point. You need a stable environment. That can be more difficult to put into play. Usually you start with something like just one environment that all the testers share, like staging. And staging is a pre-production but environment. So if it all passes in staging, you should be able to safely put it out to production. The problem with everyone sharing the same environment is you got a whole bunch of people like poking the same thing and changing things and doing things, and that could affect your tests. And it could also slow down the speed of certain things. There's a lot of weird things going to happen there, but that's one of the things you need to address. So this is when you get in from being a test engineer just writing tests to actually looking at the systems you're testing against and trying to put in quality into the actual testing, the whole testing ecosystem. And that's when you start stretching out your skills into, I'm trying to stretch my skills. It's difficult, but I'm trying to get into like Terraform, Kubernetes, all that good stuff, so I can figure out how to help out with these stable environments. But it goes back to what I'm saying before. You need to be able to like launch these environments quickly and easily. So that's, if you don't have that, that's on your plate to push out there. So another skill to do is negotiation, having conversations with people, having influence over everyone in your company. And depending on your personality type, that can be hard. My personality type, it's extremely difficult. I'm an asshole. I'm difficult to work with. I get grumpy. So yeah, I'm still learning the subtleties of communicating with my coworkers and doing things in a very positive way. But end of the day, you have to also like say, okay, I didn't win that battle today. Next sprint. That's the beauty of sprints. Tomorrow is another day. Tomorrow is another sprint. Tackle it again later. Figure out a smaller problem that devs and management and everyone will be on your side with. So you look at the big picture, but then break it down into little tiny small problems. If you can start tackling these small problems, like for instance, if you want everyone to write end-to-end tests, maybe say developers needed to at least write one end-to-end test for their feature. Just one. Not the full everything, just one happy path test. And I did that before. It's like, hey, I just expect you to write one test. And, you know, after a while, it started picking up. We started getting people doing that. It just takes a bit of convincing. And it's also, you have to be a part of that process. You have to negotiate and you have to show the value of it. So it's a lot of proving yourself, proving the tests, proving that you have testable systems, and being able to figure out how your team works, how your management looks at things, and how to introduce things in a way that doesn't disrupt everyone. And it's difficult. It takes baby steps, and sometimes you have to take a couple steps back, unfortunately. So really the main thing about this is to keep trying. Keep adding in things and keep exploring new technologies. All the cool AI stuff can definitely help out with this. If you have a way of doing these things so that the tests get automatically generated, that would be extremely helpful. Maybe, you know, having things look at these specs and requirements and the code and like have the AI generate things. I've had mixed results with AI doing all the right things all the time, but it can at least help get someone started so it's not as hard to write these tests and get them running. Another thing to look into really is also static analysis. Find tools that, so developers don't need to write tests at all. That's the nirvana, is that there's anything you can do to prevent developers from having to write tests, go down that path. You're going to have to write less tests. They're going to have to write less tests. So static analysis is one of those things. You got a lot of linters, and I think everyone is good at putting the linters in, but I've worked at companies where they don't have all the linting in there, and linting is a way of is a tool that runs through and see if you have any bugs in your code or malformed code or code not done properly, which could cause bugs. It's supposed to go through and sniff, and there's a whole bunch of different linters for whatever programming language you're in, and there's linters for websites and whatnot. Like you can have little tools that just go through and analyze your website, see if there's any HTML or accessibility issues. Like you have AXE, is a AXE for accessibility stuff. Their tools are everywhere. You even have it in the Lighthouse and DevTools and Chrome. So that there's a lot of static analysis stuff you can put into place. SonarQube, they've changed their name, so I might be getting it wrong. SonicCube, SonarQube. These guys, they have some really cool stuff that can go through and look at your code and tell you things like the cyclomatic complexity, look at like security vulnerabilities. So getting these tools and having a good set of these tools that run automatically every time a developer checks in, as soon as you get this like giant set of tools, that is a great way to help out with this shift left concept. I can actually keep going on and on about this stuff, but I'm going to end it here and, ask you, do you have any questions about this stuff? What's your experience with shifting left or shifting right, or you're just trying to hold on for dear life and write whatever test that your manager tells you to write? Let me know in the comments, tell me what your experiences are, or if you have any questions about this stuff. We all have questions about this stuff because it's a hard problem to solve in any company. But it's so necessary, it's so important to get it working, because the further left you can shift, the more stable your product, the faster you can ship code, and the less bugs you get, and the cheaper it is to make a product. Because once a bug gets out there, the further it gets up to, I don't even know what way, but the further it gets through that pipeline, like once it merges into main, the cost to fix it becomes more exponential. Once it gets into production, it can be astronomically huge to fix that issue. So the further left you can fix something, the more your company is going to make money, and you can get that nice bonus check once a year and buy something nice for yourself. That's all I got for right now. Thank you for listening. I really appreciate you hanging out here and checking it out. If you got anything from this video, I have another video here that starts going into some of the AI stuff. So that might be where you can start and start checking these out. So if you get a little value from this video, check out this video right here. It's about some of the AI MCP tools that you can use today. All right. Thank you for watching. Happy testing. Take care.